Students, in electric force and fields, we are going to start a new topic, that is electric field due to an electric dipole. Students, due to an electric dipole, we can calculate electric field at two positions. Number one, on the axis of the dipole. Number two, on the equatorial line. A point joining the two charges, which lies on the line joining the two charges, is called axial point, and a point which lies on the perpendicular bisector of the length of the dipole is called equatorial point. So let first of all we proceed to calculate electric field on the axis of the dipole. To calculate the electric field at a point on the axis of dipole, we consider an electric dipole consists of two charges plus q and minus q separated by distance 2l. From its center O at distance r, there is a point P where we have to calculate electric field. So let us first of all calculate the distance of the point P from B and A. As you are going to see, from point B, the distance of P, that is BP, will be equal to R minus L, while AP will be equal to R plus L. So first of all, we are going to calculate electric field at point P due to charge Q1. The electric field due to charge plus Q, Q1 means plus Q, is given by E1 is equal to KQ upon BP square. E1 is equal to KQ. We have placed the value of BP, that is R minus L, so it will come out E1 is equal to KQ upon R minus L square. In our previous lectures, we have studied that electric field due to positive charge is radially outward. Therefore, the value of this electric field, the direction of this electric field will be outward, that is away from B, or you can say its direction is from B to P. Here I have shown it with letter E1 vector. Now suppose we have to calculate electric field due to Q2, that is minus Q. Electric field due to minus Q charge at the point P, if E2 is equal to KQ upon, what we shall write, AP square, and the value of AP is what? R plus L. That's why I have written here R plus L square. Our second charge is negative, that's why the electric field will be inward. I have shown E2 towards left. Due to negative charge, the electric field is inward. That's why E2 is towards point A. So I have written the direction from P to B. Now dear students, at the point P, we have two electric fields. One is E1 and one is E2. The two electric fields are pointing in opposite direction. Since electric field is a vector quantity and the two electric fields are pointing in opposite direction, the resultant electric field at the point P will be E is equal to E1 minus E2. Why we have written E1 minus E2, not E2 minus E1? If you will see, you will find the denominator of this fraction is small with comparison to denominator of this fraction. That's why we can say E1 is greater than E2, or we have written E is equal to E1 minus E2. Substitute the value of E1, E2, you solve it, then you will find the value comes out E is equal to K2 R into P. What is P? P is electric dipole moment, which I have written in place of 2L into Q. What is P? P is called electric dipole moment, which I have written in place of 2L and Q. So E is equal to K into 2RP upon R square minus L square whole square. The value of K is given by 1 upon 4 pi epsilon naught. So the value of electric field comes out 1 upon 4 pi epsilon naught to R P in upon R square minus L square whole square. E1 is pointing towards right. E1 is pointing towards right. That's why the resultant electric field will always point towards right, or we can say from negative to positive charge. At an axial point, electric field always points from negative to positive charge, and negative to positive charge is the direction of electric dipole moment. So my dear students, we can say at an axial point, electric field always points in the direction of electric dipole moment. It is very important question for CBSE exams. May be asked, what is the direction of electric field at a point on the axis of electric dipole? So remember what I have told you, the direction of electric field is always parallel to electric dipole moment, or you can say in the direction of electric dipole moment. For an ideal